A massive shield, a warrior standing behind it feeling untouchable, and across from him, someone who just tilts their wrist. In that moment, everything that worked for centuries means nothing, because the masters of the East figured it out long ago. You don't have to break through a shield if you can go around it. Today, we're breaking down 8 historic designs that change the geometry of combat. Shotel, 18th century, Ethiopia. You're in heavy infantry. Your massive shield has never failed you. The enemy closes in, but something's off. He's not charging straight. He just rotates his wrist. The curved tip slides over the top edge of your shield. A sudden pull at your back, and the defense you thought was unbreakable is gone. This is the Shotel, not a straight blade. A massive crescent, engineered to reach the blind spot behind your shield. Sika, 1st century AD, Rome. You're in the arena, sand under your feet. You're holding the Sika. The gladiator across from you is hiding behind a massive full-body shield. He thinks you don't stand a chance. You charge, but you don't aim for the center. You drive the curved blade straight into the arm holding that shield. A hard lock, and that wall of defense pries open like a lever. You catch the look in his eyes. He didn't see it coming. This is the Sika, a sharply inward curved blade, built to bypass the unbreakable Roman shield and collapse the system at its weakest point. Kilij, 15th century, the Ottoman Empire. You're a heavily armored knight, steel plate. Nothing gets through. The rider coming at you has nothing but a thin, curved blade. You know it'll bounce right off. He swings as he passes, massive impact. That thin blade hits your armor like a wrecking ball because the steel doesn't flex, the shockwave transfers straight into your body. Your arm goes numb instantly, and the defense you never once questioned collapses in a single strike. This is the Kilij. Near the tip, the blade suddenly widens, a feature called the Yelman. This engineering trick shifts the center of mass forward, so a curved blade hits with the massive kinetic energy of an axe. Shamshir, 16th century, the Persian desert. You're in open terrain. You've got a spear. The rider charging at you. His blade is going to lock against your shaft and stop cold. You're sure of it. But he doesn't hit straight. As he passes, he just drags the curved edge lightly across your spear. No violent clash. Just that smooth pull. And he's already gone. You felt nothing but the wind. This is the Shamshir. Its curve is so extreme it can't thrust. It's built for one thing. At high speed on horseback, the moment it touches a target, it drops friction to zero and flows straight through. Talwar, 17th century, India. You're in a courtyard duel. You're watching for the give in his wrist, that tiny flex that tells you when to parry. He winds up for a big swing, and his wrist doesn't move, not even a millimeter. The full force of his shoulder drives straight into your guard. Your hands go numb. Your blade slips through your fingers. This is the Talwar. The secret isn't the curved blade. It's the disc-shaped guard. It locks the wrist completely, channeling every ounce of the body's kinetic energy into a single, unstoppable strike. Katana, 16th century, Japan. Bamboo forest, narrow path. You're armored head to toe. His blade is still in the scabbard. You're waiting for the draw, the raise, that first slow swing. He doesn't wait. The moment the blade clears the scabbard, that is the strike. It doesn't hit your armor straight on. It flows across the surface in one seamless arc. Before you can even react, it's already over. This is the katana. That famous curve doesn't come from the smith's hammer. It's the result of differential cooling, hot steel hitting water, contracting at different rates. The physics pull the blade into a curve that lets it flow without locking, with perfect acceleration. Yatan, 16th century, the Ottoman Empire. You're an armored infantryman, wide guard. You've got full coverage. The janissary across from you doesn't even have a handguard. You move to block him easy, but when the blades meet, there's no bounce. His inward curve locks directly onto your blade. The weight pulls it down, and your own defense becomes a trap you can't escape. This is the Yatan. It curves inward, not out. The eared handle balances centrifugal force while that reverse curve cancels the rebound on impact and locks the enemy's blade in place. Pulwar, 19th century, the mountains of Afghanistan. You're a rider moving through a narrow pass. You go to block his strike, confident your guard will deflect the blade and throw him off balance. But the moment steel meets steel, there's no slide. Your blade locks at a strange angle. All that forward momentum stopped cold, and your own force gets turned against you like a lever. You see it in his eyes. He expected exactly this. This is the pole war. The secret isn't just the curved blade, it's the steel guard that bends directly toward the pommel. The downward geometry isn't built to stop a strike, it's built to trap it. The battlefield was never just about who had the thickest armor. Sometimes the right angle beat the hardest strike. The masters of the East pushed the limits of physics, forging legends that bypassed shields and controlled momentum. Which of these 8 designs would you least want to face? Let me know in the comments. The next design will surprise you. Stick around.